Hello students, so today we're going to talk about simplifying expressions with negative and zero exponents. And to be honest with you, this is one of my favorite topics, and I'm gonna let you know later why is that. So let's begin. If the base is powered by the negative exponent, then the base becomes reciprocal with the positive exponent. So what is that thing? It seems so confusing. Well, sometimes when we talk about exponents, you may see examples like this. 8 to the negative 3, maybe b to the negative 4. So those are examples of negative exponents. And there is an official rule that says we can't leave negative exponent. We always have to convert the negative exponent to a positive. So, in order to make it positive, if you have given variable with the negative exponent, what you need to do is you have to flip the negative with the denominator of 1. So here's what this means. X to the negative m is the same thing as over 1. Now to make this positive, you put this down, you flip the two terms. This goes down and becomes positive, and 1 goes up. So 1 over x to the m will be the new look of the exponent and will be the right one because it is positive. And here's an example. If I have 5 to the negative 3, this is the same as 5 to the negative 3 over 1, okay? So now to make this positive, I need to move the number down here from numerator to become denominator. So 1 goes on the top over 5 to the third power on the bottom. Same thing over here, 8 to the negative 3. So this will be equal to 1 over 8 to the positive 3. b to the negative 4. This will be equal to 1 over b to the positive 4. So your job is always, if it's a negative exponent and if it's on the top, you move it down, make it positive. If it's already on the bottom and you want to make it positive, you're moving the term up as a denominator. And we will do some examples together so you will see. Okay, so we have given variable with negative exponent, we're moving down, it's 1 over. Now here's another case when we have 1 over 3 to the negative 2. It's already in the denominator side, it's negative. So now we're gonna move it up and we will say this becomes positive when we write the same thing over 1. So basically you just need to exchange the positions of the negative exponents, move it from top to the bottom, from bottom to the top in order to make it positive. That's all what you need to do. Sometimes if you want to kind of picture that, let's say you have 3 over 7 to negative 2. Okay, so this will be another fraction. 7 to negative 2 will go up and change to positive, and number 3 now needs to go down. The same exact number. You're not changing anything, you're just flipping those numbers to make them look positive. Okay, well, I hope so far you guys have some type of understanding. We will do together some examples for sure in the classroom, and you will have opportunity to practice with some of those, so trust me, you will become experts with negative exponents. Now, zero exponent. This is my favorite part, and let me tell you why. Zero exponents, doesn't matter what base you have. If they have a power of 0, the answer is always equal to 1. So, if I have x to the 0, will be 1. If I have 5 to the 0, the answer is 1. If I have inside the parentheses 3 times a times b squared, this whole thing, look at those parentheses, so this whole thing, like a box, is to the 0 power, is again equal to 1. If I have a big, even larger box with so many things inside, who cares what is writing here? 2 times 3 plus b squared to the 500th power. If this whole thing is to the power of 0, the answer is simply 1. You don't need to calculate anything. So that's the good thing about zero powers. It's pretty awesome because you simplify right away, immediately, and it's always equal to 1. Alright, well, let's take a look what we have on the next page. So on the next page, I have to evaluate a few expressions. And let's begin with the first one. 3 to the negative 2. Now, 3 to the negative 2, if there is no denominator, make sure you write 1. This will help you to remember that you have to flip those numbers to make it positive. So, I'm going to draw a line here, fraction line. I'm going to move 1 on the top, and 3 to the negative 2, write it down as a positive exponent. 3 to the positive 2. And that will be my final answer. In the next example, we have 2 to the negative 2 times 2 to the negative 5. Well, remember from previous lesson when we multiply two powers with the same base, we say the base will be equal to what? We add those two exponents. So let's add negative 2 plus negative 5. That will be equal to, what is negative 2 plus negative 5? It's negative 7, 2 to the negative 7. Okay? But now, may I leave it like this as a negative exponent? No, I need to change that. It's not acceptable numbers to stay with negative exponents. So again, 2 to the negative 7 is the same as over 1. So we put 1 on the top and 2. Now change negative to a positive 7. 1 over 2 to the 7th power will be my answer here. Okay, next example. We have 7 to the negative 6 times 7 square. Okay, 7 is the base, and again will be negative 6 plus 2. So that is equal to 7. Negative 6 plus 2 is negative 4. 7 to a power of negative 4. Okay, well, again, we want to change that to a positive. Write down over 1 denominator and flip those two numbers. So 1 on the top, 7 with positive exponent of 4 will be the final answer. Very good. Next one. What about 13 to the 0 power? It is equal always 1. Negative 3 to the 0 power? Same thing. It's always equal 1 because of this 0 power. So those are very quick and easy to solve. Then we have negative 14 to the negative 2. So this is a negative power and we have negative 14. Just like those. Okay, you're going to put over 1 and we're going to flip those and we'll say 1 over. Now be careful here, very common mistake. If you have negative 14 inside the parentheses, this is not the exponent, this is the base. So if it's the base negative, we keep it negative. What do we change as only the exponent make it positive? So 1 over negative 14 to the 2nd power will be the final answer here. In the next example, we have x to the negative 5 times x to the negative 10. Okay, x and x base, and again we're going to say negative 5 plus negative 10, which is equal to x. Negative 5 plus negative 10 is negative 15, and this will be equal to 1 over x to the positive 15. Final answer here. Another example. Y to the negative 11 times y to the 5th power. So base of y and y, negative 11 plus 5. This will be equal to y. Negative 11 plus 5 is negative 6. So we have y to the negative 6, and we need to convert this to a positive, so it will be 1 over y to the power of 6, positive 6. Final answer. Okay, well, we have a few more examples, actually 3 to go. They will be very quick one, I think, because you will remember when we had division examples what we did with the powers and their base. So let's follow those divisions rules. In the first one, we have 12 over 2. This is one pair of the same powers or numbers. 12 over 2, this could be simplified both are even numbers, they're divisible by 2, so this is 6, the top becomes 6, the bottom 1. If you want to write down 1, write it down. If you don't, you can just leave it without 1. And the next one is this. We have k, and remember we said negative 6 minus 2. So now with the division exponents, we subtract them. Remember division, we subtract the top one minus the bottom one. That's why I have negative 6 minus 2. Okay, so this will be equal to 6 and 1. Now k, what is negative 6 minus 2? Negative 6 minus negative 6 minus 2 is negative 8. And this will be equal to, now we're gonna flip those, okay? So we write 6 and 1. We don't change those because they don't have negative exponents. The only one that has negative exponent is this, and we have to move it down, and we'll change to k to the positive 8. And that will be the final answer. Okay, let me see what does it stuck here. Something stuck